Hello everyone, in this video I'm going to discuss an example for first order differential equation. Newton's law of cooling states that hot liquid at temperature H, cold at the rate, we have the dH dt, proportional to the difference between its temperature and the temperatures of the surrounding environment, H0. So here we have the situation given. So we have the dH dt equals to the negative K, because cooling multiplied with the H minus the H0. So by using the separable variable, we have the dH dt. So here we have the negative K, then here we have 1 over the H minus the H0. The following step will be add on the integration sign. So here we have integrate 1 over H minus the H0. As we all know, the H0 is the temperature of the surrounding environment, which is a constant with respect to H. So here we will have ln modulus H minus the H0 over the 1 equals to negative KT plus the C. So rewrite the situation, express the H as a subject. So we have the H minus the H0 equals to, we have exponent negative KT plus with the C. So we can making use the rules of indices. So H minus the H0 equals to exponent negative KT multiplied with the exponent C. So let the exponent C equals to A. So rewrite the situation. H minus the H0 equals to, we have the A multiplied the exponent negative KT. So H will be equals to A exponent negative KT and then plus with the H0. So we already shown the situation given. Next, show that we have the H equals to A exponent negative KT plus the H0, where the K is a cooling rate constant and A is the integral constant. A hot T, so here we have the temperature. H is equals to 76 degrees Celsius, is left in the room temperature of 22 degrees Celsius. So meaning that the T is equals to 0 and the room temperature we have 22 degrees Celsius. So kindly substitute the situation. So here we have the 76 equals to A exponent negative K bracket 0 and then plus with the 22. Kindly rewrite the situation. So in here we have 76 minus the 22 where we have 54 equals to the A. Finally, H is equals to 54 multiply the exponent negative KT plus with the 22. So that is the Newton's cooling equation. Kindly refers to B. Using a container X, it is found that after 10 minutes, so means that T is equals to 10. In the room, the temperature of the T has decreased by 10 degrees Celsius, so meaning that now the H is become 66 degrees Celsius. Determine the temperature after 15 minutes. So the second question is T is equals to 15 minutes. What is the H? So kindly substitute the situation given. So number 1 we have H is equals to 54 exponent negative KT plus with the 22. So T is equals to 10, H is equals to 66 degrees Celsius. So if we substitute the situation, we have 66 minus 22 over the 54 equals to exponent negative, we have 10K. So find the K. So here we have ln bracket, we have 44 over the 54 and then divide by the negative 10. So here we have the value K. Ln bracket 22 over 27 over the negative 10. Or we can say K is equals to 0.0205. Next is to find the temperature after 15 minutes. So in here we have H is equals to 54 exponent negative 0.0205 T plus with the 22. So T is equals to 15, H equals to question mark. So now we have to substitute the situation given. So H is equals to 54 exponent negative 0.0205 multiplied with the 15 and then plus with the 22. By referring to the calculator, and we have the temperature 61.72 degrees Celsius. C. Using the different container Y, whose K C. Using a different container Y whose K is 0.1. Determine the time taken for the tea to cool down to room temperature. So here we have the situation H is equals to 54 exponent. We have the negative 0.1 T plus with the 22. So question said we have to find the time for the situation to reach the room temperature 22. So kindly substitute the situation. So if we substitute 22 equals to 54 exponent negative 0.1 T plus with the 22. So rewrite the situation, we have 0 over 54 equals to exponent negative 0.1 T. So we have ln the situation 0 over the negative 0.1. So the situation will be T approaching infinity. So meaning that we can't get the 22 degrees Celsius or the room temperature. Then we need to wait after a very long period of time. Then kindly refers to D. In which of the two container, X or Y? So the X we have 0.0205 and the Y we have 0.1. So does the tea cool down to room temperature faster? So for this case, Y will be the fastest one, because refers to the cooling rate, we have 0.1 greater than the X, we have 0.0205. So Y faster than the X.
Thank you so much for watching this video. If you think the video is useful, kindly consider to like, comment, share and subscribe.